So now, yesterday we were covering how to find a binary value of a decimal number, which was an integer, a decimal integer, like 47, 100, 55, 132, and all those things. So we developed a method, right? So today we will develop a method for how to do decimal to binary conversion for points after the value after the decimal point. Yeah, what we call as fraction. Okay, so just the basics, just to get the basics now. What we said, if you have a number like 0.7, assume this is 0.7, how do we represent that? What's the point? So this is 0 and this is 1. And if this is central point, if this is 0.5, where will this fall? 0.7, first half or second half?
First half.
Are you sure?
I mean second half.
Okay, 0.5 and 1. This is between 0.5 and 1, right? So this is second half. That means the first decimal is 1, right? Like the trial and error method. First point
Yes.
is 1 because this is 0.5. So we have to start from 0.5, not from 0. So this is 1 by 2, right? The first point after decimal, the value is 1 by 2. Next one is 1 by 2 raised to 2, that is 1 by 4. Next one is 1 by 8. Next is 1 by 60. Next is 1 by 32. So this value 1 by 2, that is 0.5 or half. So our value is between this and this. So our first point is 1, right? Now second point. Now this point is 0.75, right? So second point is, this is 0, this is 1. Which one is second point?
0.5 to 0.75.
Yeah, so that means it is 0. 0.7 you know is between 0.5 and 0.75. So the second decimal is 0, right? First decimal is 1 because now you know this is between this and this. And second decimal is 0 because you know this is between this and this. If it was 1, if this was 0.8 or 0.9, we would have put 1 here. Right? This is the 1 by 4 accuracy. This is divided into 4 pieces now. 1 piece, 2 piece, 3 piece, 4 piece. I haven't marked this one, that's all. Right? Now the third part, this is 0.625. So that means now we know this is between 0.5 and 0.75. Now the third decimal is to give an accuracy of 1 by 8. So now we want to know whether it is between 0.5 and 0.625 or 0.625 and 0.75. This is 0, this is 1. So third decimal is 0 or 1?
1.
1 because 0.7 we know it is between this and this. So third decimal is 1. Now we want to add further accuracy. 1 by 16, the fourth point. So we divide the whole piece into 16 pieces. That's why everyone we divide into 16 pieces. So this value is 0.6875. So the fourth decimal is 0, then the value is between 0.625 and 0.6875. If it is 1, it is between 0.6875 and 0.75. Accuracy is brought to 0.1 divided by 16. So what is the fourth decimal?
1.
1.
It is 1 because it is between 0.6875 and 0.7. Like this you can go on. If you want to add further accuracy, you will make this into half and see whether it is between this and this and this and this. Like that you can go on adding. You understand? Do one, then you will know. Try doing one. Trial and error method. So make a diagram like this. Divide and see whether this falls into first half or second half. That means you got it into an accuracy of 0.5 or half. Then you look at the next decimal. Wherever this falling, divide that half into 2 and see where that falls. First half means 0, second half is 1. Again. Anyone got it? Up to some 3 or 4 decimals you can do. See, further decimal means further accuracy. So any number you can represent into any more decimals like this. More decimals means more accuracy. But you won't need more decimals if this falls on any of this point. Let us assume this point is 0.5. Then you
Is
need
it 0, 1? Is it 0, triple 1?
It cannot be 0 triple. The first one cannot be 1 at all. First one is 1, that means it is the second half. You see 0.3, you know 0.3 falls somewhere here, right? Right? So it can never, first digit can never be 1. It can be 0 only because this is in the first half.
So can it be triple 1 0?
Look at this now. See, what does it mean? 0.3. 0.3 means, let us start doing, okay? So if I make decimal point, which will be the first decimal? That depend on whether it falls on this or this. 0 to 0.5 is 0, 0.5 to 1 is 1, right? So 0.3 is between 0 and 0.5, right? This is our point. Is it not?
Yes, sir.
So the first one is 0, right? Now second one, further accuracy we want, we have to make this into 2. So what is this value? What is this point's value? This is 0, this is 0.5. What is the center?
0.25.
So that is 0.25, right? Excuse my writing. It's 0.25. Now 0.3 is obviously is in the second half. So which means second is 1. Now you want further accuracy. So between 0.25 and 0.5, you make this one. So what is this point? This could be, what is this point? What is the value of this point? Between
0.375.
0.375, right? Between 25 and 50, you see it is 0.375. So this point falls on again the first half. So then this is 0. Now you want further accuracy, you draw between 0.25 and 0.375. Then this will be 0.3125 or something. So it is further 0. You go on doing that, you get further accuracy. Yeah. Now you tell me, when will be the case we can represent a number with only one point after decimal in binary? There's only one decimal number which you can represent with 1 point after decimal in binary. It's 2 points, 2 values.
1.
1 is not decimal. After decimal, one is decimal means after 0 point something.
0.25?
0.25 you need 0.25 you can't represent with 1 because if this you see if this was 0 then the value is 0. If this
0.2.
If this is 0, value is 0. If this is 1, value is 0.5. So 0.0 and 0.5 are the only two decimal values which you can represent with only 1 point in the binary. So binary 0.0 is this. Binary 0.1 is this. Now if it was 0.75 or 0.25, you can manage with 2 decimals. Right? If it is 0.25, it is 0.01. If it was 0.75, it was 0.11. This is 3/4, this is 1/4. So if it is falling exactly on any of this dividing point, you can stop there. If not, you have to go further. Yeah, so I think we can stop it at this point. This much clarity is decent enough for you. But you know now manually how you do it, right? This is what is called trial and error. So our job is not done. Okay, we only started. This is only trial and error method. Now you think, apply your brain. How can we devise a mathematical process? Like we design something for getting like 4730, the full integers, how we converted, divide, successively dividing by 2 we converted, right? Like that you think now, what is the best method to do this whatever we did with trial and error method? Mathematically, algebraically, arithmetically, what is a method to do this? Think of it. I'll give you a clue. If you know it, you tell me. If you don't, I will give you a clue.
Clue first, sir.
Clue first. Okay. See, now clue is there in what I told now. So what did I tell now? If this was 0, you need only 1 point after the decimal, 0.0. And if this was 0.5, then this is 1, right? If this was value was 0.5, then in binary this is 0.1. First value is 1. Is it not?
Yes.
If the decimal value, if you want to represent 0.5, in binary it is 0.1. Only one decimal you can mark, it is 0. So 0.5 in decimal is equal to binary 1. So what you do to 0.5, you get 1. What operation if you do on 0.5, you get 1?
Multiply by 2.
You multiply by 2. Yes. Right? So it is as simple as that. If you just multiply, let us go with the same 0.7. Just multiply it with 2. What will happen? The value you will get is 1.4. So what did we effectively do? We effectively doubled this number and we realized 0.7, when we did, how we did? We looked at 0.7 falls between 0.5 or 0.5 to 1, right? Is it not?
Yes.
How we did? 0.7, first we saw whether this falls between 0.5 or 0.5 to 1. We realize it is between 0.5 to 1. First one is 1. Instead, we multiply this with 2. So what happens? If this is more than 0.5, the resultant number will be more than 1, right? 0.5, if you multiply by 2, you get 1. 0.6, you get 1.2. 0.7, you get 1.4. Any number before this, if you multiply with 2, you will not get a value more than 1. If it is 0.4, you will get only 0.8. If it is 0.3, you will get only 0.6. So think about that beauty of that method. If you just multiply this number with 2, what you get, if it is between 0.5 and 1, you will get a value more than 1. If it is between 0 and 0.5, you will get a value less than 1. Do you get that?
Yes, sir.
Yeah. Now you see. So you multiply this 0.7 with 2, you get 1.4. What if you add that 1 that understood this position is 1 then? Now you want to get the next position. Now we know our 0.7 falls somewhere here. So we want to get the second point. So what did we do? We divided, we understood this is between 0.5 and 1. But now we want to know whether it falls between 0.5 and 0.75 or 0.75 and 1. We want to know that, right? We want to know if it is this between this and this, value is 0. Between this and this, value is 1. We know 0.7 falls between 0.5 and 0.75. That is why this became 0. But in our case, when we multiply 0.7 with 2, we will get 1.4. If you again multiply 0.4 with 2, you will get 0.8 because this is falling here. So it is a bit tricky. Multiply with 2, you get 1.4. Again multiply with 2, you get 0.8. You will know this is in that falling in that 0 position. Again multiply with 2, you will get this 1.6. Again multiply with 2, you will get 1.2. So this value actually is 1011 is exactly what we found out here, 1011. So what is it actually doing? Just now you apply your brain. This operation called into 2, what it is doing? If you multiply, now we know 0.7. If you multiply, whatever value we get is more than 1. So you understood the first value is 1. And second portion is 0.4. See, 0.4 means it is here. So if you multiply it again with 2, if it was here, if this number was 0.8, then into 2 you would have got 1.6. Then the value would have been here. Then if you multiply 0.6 into 2, you would have got 1.2. That means this falls on the one side. So you go and look at it. So the mathematically, if you multiply each time with 2, actually it will tell you whether it is falling on this side or this side, this side or this side, this side or this side. Same thing what we did here with trial and error is what happens when you multiply this with 2 successively. So each time when you multiply with 2, this will show you whether it falls on this side or that side. If it is 0, it is falling on this half. If it is 1, falling on the other half. So take a number 0.7 or 0.3 or something. You do first by trial and error after this class. And then on the other side, right hand side, you do this and spend some time. Then you will be able to read the mathematics of it. Yeah. So what you did by trial and error is exactly actually what we are doing here. So now you know why I called this course number games. Yeah, this is playing with numbers, making meaning. See, this is very simple. Multiplying successively, multiply. So and take this. So this value is 1, 0, 1, 1, 1, 1. This is simple part. The beauty is in knowing where from this method came. What is the rationale for this? And you keep on multiplying, your accuracy will keep on increasing till you get 0. Okay, so just go home and try doing for some numbers 0.5, 0.3, 0.55 like that. See, if I keep on doing this, the accuracy will keep on increasing. Okay, so I am giving you 2 homeworks. So find the binary value for this. I will tell you right now. You can't do this together. Okay, first you find the integer side by dividing by 2, and then the point after the decimal is by multiplying by 2. So both you have to calculate separately. Okay, so how you calculate integer side, how you calculate decimal side is 2 different methods. Integer side you successively divide by 2 like how we did yesterday, and the decimal side successively multiply by 2. So you will get 2 values, then you add those. So you will know the representation of 10.6 in binary. Try doing same thing. Yeah? Others, everyone?
Yes, sir.
Yes, sir.
Okay. So with this, we are packing the number business. Okay? So we are now getting into something called toffee maths. So what is toffee maths?
Not sure.
Problems with simple things like toffees.
Yeah, toffee maths is this.
15.
Toffee maths is the maths which you do when you go to buy toffee. As expected, Avinash did 2 steps together.
No, I divided 40 by 8, then multiplied it.
So that 40
By
by
3.
8 is the step 1, right? How you did it? How will you do a problem like this? What is the method?
Divide total cost by
Dividing and
number of
multiply.
copies.
Yeah, so that's always understand the method in simple problems. So the mistake sometimes you do is in the simple problems you won't try to understand the method which you applied, and you will go to complicated problems and try to understand the method which you will not understand. So now you tell me, what is the method you divided and multiplied? Why you divided in the first place?
Because 8 toffees cost something, that is 40.
Okay.
So if you want to get 1 toffee's cost,
You want to get 1 toffee's cost, right? So you want, if you get 1 toffee's cost, you can find the value of any number of toffees by multiplying. So that is the method. So that is what you have to understand in this. The method is, you have 40 rupees which is divided into 8 toffees, right? So you want to know 1 toffee cost. This is what we call as unit value. Unit is what? Unit value of 1's value. Why are we doing 1's value? If we get 1's value, you can find it for 3, you can find it for 25, you can find it for 25 raised to 10, you can find the value. What is the value of 0.257 toffees? So you don't ask me why you want to buy 2.57 toffee. Then I will ask you different problem. 1 kilogram gold costs 35 lakh rupees. How much for 0.257 kilogram gold? Then you will tell, sir, I want to do more decimals because gold is precious. Right? You don't want to lose a gram. Tell me, how will you calculate 0.257 toffee? How will you calculate?
multiply it by the rupees
By
5.
the unit value, right? So that is the beauty of unit value. If you get the unit value, you can find out any values, right? So that is toffee maths. Don't forget this now. Okay, now I will get into some other problem. You will all forget toffee maths and you will run behind certain things. Just understand this very simple principle. 80% of mathematical, physics, chemistry, science problems can be solved by toffee maths. We told 1 toffee maths. I will tell 2nd toffee maths. Only 2 toffee maths are there. With that, we can solve 80% of science, physics, chemistry, biography, geography problems which you have to encounter. Okay, right. But some people have this habit of making things complex. Okay, so that they get a thrill or things like that.
6 cakes, right?
Yeah. So yeah, you all know the answer. So you are not studying in LP school. So to ask this,
12 cakes.
I want to know the method.
12?
1 cake costs 50 rupees. Then how we can buy 600 rupees? So we could divide it by the cost of the cake to get the number of the cake.
So what are we trying? Why you divide it?
To get the how much number of cakes of that particular cost.
Why you divide?
Rupees 50.
What is the reason for divide? Why you are not multiplying?
Because we want to buy an amount of fixed 600, so we want to divide it by the cost.
But why division?
To find the number of cakes.
It's the method. He's sticking to the method.
Yeah, why you know it is division? I am telling why it is not subtraction. What if I 600 minus 50, 5?
Because that's the method.
Yeah, why? What is the reason?
Because each cake costs 50.
Okay, so
So we must divide.
Why?
Sir,
Divide
to
the.
distribute the value.
See what are we telling? 600 rupees we have. We want to distribute this 50 into 600 and see in 600 how many 50s are there. Actually, Avinash and Adnan's mind works that way. But the skill has got into your head that you have forgotten that this is why you are doing it. Because the skill has come. It is like you ride cycle. Okay, so suddenly when somebody asks you by telling that, okay, you know, if you just travel, ride in India, if different parts of the India, when you ask for road direction, like I have been to drive extensively, in different parts people show in different manners. In Tamil Nadu, so you ask, the Trichy and the Pakam, sir, straight up and go, right. So you have to believe his hand. What he said is wrong. So his hand is correct. So actually it is left. That's why he's showing this. But normally, what he will tell, you know, he will tell right and show left. So we normally see some drivers know, you know, you have to believe his left. So always you have to look at his hand. Where was it turning to left? Okay, don't bother about what he told, right? Because his skill, so much skill he has, so he is visualizing that road and then telling. You are in Kerala and you ask road direction whenever you ride. So you will ask, boss, കുന്നംകുളത്തേക്ക് എങ്ങനെ പോകണം? ഇവിടെ നിന്ന് 1.5 കിലോമീറ്റർ പോയാൽ ഒരു ചോപ്പ് വീടുണ്ടാവും, അവിടുന്ന് മൂന്നാമത്തെ വീടിന്റെ റൈറ്റ്. Right? So he will get into mathematics. In Kerala, most of the time they will get into that pinpoint, X point, 1.5 kilometer you go, there will be a red color house, and from there you take right and this. And that landmark will be pakka. This 1.5 could be going a bit wrong because it could be 3 kilometers or something. But you know that red color house, that he can never go wrong. So like people's habit, you know, you based on your habit, you will be having some skills. So and if you go to the north side of it, you ask for the road sign, it is entirely different way. So they will tell, sir, सीधा जाओ, आगे गोल चक्कर से उल्टा. You understand? आगे गोल चक्कर से उल्टा. You know what it means? Goal checker is roundabout.
U-turn.
Goal checker is roundabout. Goal checker, yeah, is roundabout. Ulta means wherever you are going, the opposite.
Opposite.
Yeah. So the whether you are, so if you are going this way, ulta is this. So he meant whatever he showed by hand or something, you don't believe that ulta will be correct. You know. So that is a skill set. So like that, Adnan and Avinash knows it very well. If I have 600 and one cake costs 50, I have to divide. But if you don't understand the method, if I ask you 1 mole of hydrogen, how many atoms it has, you will have some slight trouble. Because that is the time you will search for a method. So you clarify the method here. Okay, so what Ritesh said is the crux of it. You are dividing 50 into 600 and seeing how many 50s are there in the 600. That is what actually you are doing. In your mind it is there. So which is what we call as division. In 600, how many 50s are there? The previous problem was a reverse of this. Slight reverse of this. You understand? You get that, right? Okay. So now you know this. Now let's get into some simple problems. Just to see that it's a push-up for you. before we get into the actual weightlifting. Some push-ups. Shivananda knows it. No? Before she goes for that Shirshasana and other kind of, she will do some warm-up, right? Yeah, so these are warm-ups. Tell.
20.
20.
Yes. So this is same problem. You are asking in 600 how many 30s are there? So in 600, 20 30s are. Okay, now this one. It's the reverse of it. Right? We know 16 classes are there. So we
40
are,
students.
so we are understanding 640 students are equally distributed, like what are these students? Equally distributed into 16 classes. So in one class out. So you know, it's the same thing, right? Okay. Now let us get into weightlifting. Okay. So this gentleman called Eratosthenes applied toffee maths around 2200 300 years before and calculated circumference of Earth. Okay, so we will try to see how he did it. He was living in a place called Siam near Rome. Okay, he realized that certain parts of the day sun is coming exactly above your head near this place. Okay, how you know it? Sun is coming exactly above your head.
He looked.
What?
He looked.
Yeah, but when you look, you will see sun is above your head, right? Otherwise, also, you can't like straight away look like this at sun also.
The shadow.
Shadow, right? But sun is almost on your head, there will be shadow, right? So he realized, he looked into a well. He always marked that well. Center of the well, you can see that round sun. There is no shadow. So he realized that is the time sun is coming almost straight on the head. Every year he monitored. You see the struggle those people have made in order to find out these things. So after a few years observing, he marked that day in the calendar. This is the day it is happening. Next year, much days before, he traveled 800 kilometers and went to another place within his country, Alexandria. Why he went there? He wanted
To test.
he wanted to get a place where sunlight is not above the head. He knew that sun is much bigger than Earth. That means everywhere you can take sunlight as parallel. And there he climbed on a pole. He had identified this. So he knew there, the Earth's shape is spherical, which means if this is straight like this, this will be like this. And he knew if you draw a straight extension from here and here, this will go and hit in the center of the Earth. That is scientific knowledge. So he knew this. That is the scientific knowledge he had. So he went there and measured the angle the shadow is making. He got it as 7 degrees. So what did he do? He was knowing that sunlight fall parallel, straight, and he knew that this specific day in the year, sun is exactly above this. He knew if you travel, why he traveled 800 kilometers, so that you get a reasonable angle, very less angle, 0.1, 0.2 degree means you can make calculation error. So that time also you had astrolabes and all those things to measure angles. And he measured this angle the shadow is making, which he knew if you extend this will come and hit the center of the Earth. And from this, it is only back of the envelope mathematics, Toffee maths. How can you calculate the circumference of Earth with this much info?
So was the value of pi was known?
No. Value of pi was known, not that accurately. But you assume
So,
you assume it was known. Let us see what you do with that. Yeah, Adnan.
no, if you like any point on Earth, if you draw a line, it will meet the center of the Earth, right? So what's so special about this point?
Yeah, that is what you have to think. You have to this point is only to get you an angle. So if it go any point, if you draw, it will come to the center of the Earth. You are right. There's no doubt. So why he did this? Good question.
So the sun rays and the radius are parallel. So vertically, we could get, if we could get the angle of them, we could get the angle of the two radius. Then what?
Good. See, this is where I'm saying that fundamentals are important. This is actually simple toffee maths. See, if you forget about fundamentals, if you do 2 steps, 3 steps and all those in toffee, because those are simple numbers, you know the answer. See, what you are doing there, you know the answer by seeing the problem itself. You 8 toffee is 50 rupees, what is 3 toffee? You know the answer. Then all other things which you are explaining is to get into the answer. So that is the time you should make your brain work to understand the process, fundamentals.
So how to find the angle, sides of a triangle? I completely forgot it.
Actually, it is toffee maths. See, Sam has already found out an answer.
Comparing to the steps of the normal toffee maths, should we divide 7 by 800?
That is where you go wrong. That is where you are trying to by heart a method. You are not applying the method. You are not applying the method.
If we could find the radius, we could easily find it. For finding the radius, we got the angle. Then how I don't know how to find the
angle. Is the angle 7° and angle E same?
Now Adnan is making some sense. See, actually, this mathematics was kids' play for him. Don't think Eratosthenes spent this much time to get the mathematics. Mathematics for this was kids' play for them, back of the envelope. Doing this method, identifying that sun falls straight on this, getting this diagram, traveling this much, doing this measurement. That method is where the innovation is. Mathematics of this is child's play. Adnan was making some sense there. But you tell me fundamentally, see, you are not applying your mind. What is circumference?
800 kilometer, so 360 meters.
Correct. You see now, it's a very simple thing. What is it that you have to find? What is it that we are doing till now? So you forgot all those things. The problem became complex. You forgot all toffee maths. What are we finding out here? You are finding out here in 640, in 600, how many 30s are there? That is what you are finding out. Is it not?
20.
Yeah, that you know. Because it is a simple problem. Now, if I am telling you this
7 to 800.
If this length, assume I am telling you this is 5 meter. What is its circumference? If I am telling you this arc is 5 meter, how do you calculate
150.
That is until you are jumping into answer. Avinash, I am repeatedly telling you this will trouble you. You are not ready to correct. You just go one step at a time, because when the problem is simple, you are jumping 3 steps. That is why you are missing the bigger problems. How are you doing? You think of it. If this is 5 meter, how will you calculate circumference?
5 into 20.
5 into 20, because you will see how many such arcs are there in the whole circumference, right? Yeah, Vinesh? So you will see how many such arcs are there, how many such angles, how many such portions are there, how many such cones
5
are
into
there.
20 will become 100, not 600, right?
Yeah, 600 by that means you are telling in this whole stuff you have 20 such cones. So if each cone's arc is 5, it is 20 into 5. Is it not? See, all what you have to find out, here is how many such cones are there in this whole circle. If it is 10, 10 into 800. If it is 20, 20 into 800. If it is 30, 30 into 800. Yeah, do you get that? What is circumference? Circumference is like this, how many cones are there? That is why he traveled 800 kilometers to measure this angle, to get to know what is the size of this piece compared to the whole circle. Oh, with this much you have to answer. How will you calculate how many such cones are there in the whole earth?
7 divided by 360.
7 divided by 360 or 360 divided by 7?
The other way, yeah, 360 divided by 7.
Yeah, why? You see, that is why you need to calculate this angle. See, you want to know like this, how many cones are there. For that, you need to measure this angle. To get this angle is why this gentleman traveled all that way. So that if you travel all this way, you get this is 7. You know, if this is 7, then this is also 7, right? This is opposite angle. And if this is 7, then you know this is also 7. This angle and this angle are same. This, right? Yes or no?
Alternative angles are also same.
Yeah, you are by hearting
Yes.
it. Forget about by heart part. Where from it is coming? It is coming. You don't have to by heart anything in this. This angle and opposite angle are same, which is a phenomenon. Like, you know, anything, if you keep an angle like this, if you reduce the top one, bottom one also will change. If you increase this one, the opposite will change. So opposite angles are equal is a physical phenomenon. You don't need to by heart anything. If this is 7, this and this are same. So now you know 7-degree angles, how many are in a circle? 360 by 7. Right? So that means that many cones are there. Multiply with 800. Goes 2300 years back. People did all those things without much of an issue. So the problem reduces to this. This is our toughy maths. Is it not?
Yes.
Yeah, so that is why you have to understand the fundamentals of toughy maths and then you apply. If you have doubt in fundamental, you will have problems. Right? Now the problem reduces. So to get this is, see, he knew this angle. If you measure that angle, you will get this angle. Now at night, do you get answer to your question? From any point you can draw. Why did he go there?
I see.
He went there so that he get a reasonable number. This very close means 0.01, 0.2 or something. You can make mistakes there because you are calculating for the whole earth. And he got a value which is very close to today's value. You know, with this method, right? So 7-degree makes 800 kilometers. You can do your toffee maths also. 1 degree makes 800 by 7. 360 degree makes into 360. This is actually what you did in toffee maths. 8 toffee, 50, how much was that? 40 rupees. 1 toffee 40 by 80. 3 toffee into this. But when the numbers become complex, we will forget all toffee and everything. Yeah, that's why the fundamentals has to be right. So we will learn driving the car. Okay, we will know everything. This is gear. This is something. This is everything. Suddenly on a main road, lot much traffic, and many people do horn. We will forget. Oh, if I press this one, this will go front or back. You will get all kind of doubts. Right? So that is why in a slow terrain, good terrain, you do all kind of practice so that it becomes the fundamentals become clear to you. Is this clear to all of you?
Yes.
Yes, sir.
Yes.
You are ready to take a jab at more complex problem. This you can do it like this also. Number of 7-degree arcs in the circle is 360 by 7. It's two methods. We learned two methods of toffee maths, right? You can do two methods. Either you calculate for unit value 1 degree, multiply by 360, or you see how many 7-degree arcs are there in the whole circle, 360 by 7, multiply. Both are same. 800 by 7 into 360 is same as 360 by 7 into 800. These two methods which we learned.
So there's many decimals.
Come again?
There's many decimals.
Yeah, there could be, he got reasonably correct value, this guy. See, this 800 by 7 into 360 is same as 360 by 7 into 800, right? You just replace 800. Okay, now, you take a normal circle. This is radius, this is radius. Assume this is the radius. You draw an arc which is equal to the radius of the circle. This is like a equilateral triangle, only thing this side is not straight. What is this angle called? This angle made by an arc length is equal to radius is called what? What is this angle called? Have you studied?
60-degree.
Okay, first of all, it is not 60-degree. Second, we will come to that. It is close to 60, you are right. What is this called? There's a name for this angle.
Right angle?
Is this right angle?
No.
Is it acute angle?
Okay. See, there's a peculiar name for this angle. That is like, you have seen this movie Yendiran. So in Tamil, you will see most of the Tamil, their beauty is that they will find out a word for most of the new kinds of innovations, right? For mobile phone, there's a Tamil word. You know what?
No.
It's called kai pech. Pech is actually talking. Kai pech. Very simple, right? Very cute. Okay. For robot, there is a word in Tamil. Robot. There is a famous movie with that name. And this Riddhish should be hit on his head. Riddhish and Sriyesh. These guys don't know the Tamil for all this which I am asking.
Endiran?
Yeah. That's Sriyesh and Riddhish. You guys will be outcasted from Tamil. Yeah? If you don't tell Tamil words. Don't you know the word Yendiran? Haven't you heard?
So for technology.
What?
Sir, Endiran means technology, right?
No. Yendiran is robot. See, Yendram means machine. So robot,
Machine, yes.
Yeah, so robot is Yendiran. What is your mother tongue, Adnan?
Same as yours. Kerala.
Okay, so Yentram is machine, Yendiran is robot. So these people actually, I think, did the Yendiran Tamil kind of stuff. This is radius. The angle made by radius is called radian. Okay, like Yendiran, it is called radian. Yeah, this is a very important word. This will come behind you throughout. The game with radians are going to start from +2, I think.
So it's like a slice.
Slice made by one radius, one length radius. Now, after some point, you will use
Aren't there
mostly.
two radius? One is the R and then the other one is the one on top.
Yeah, but the arc length is one radius. Arc length. So 1 radian is the angle made by an arc length equal to the radius. Get it?
I see.
Yeah, and this see from actually later you will use only radians for angle measurement for angle mostly. We will see why. So now the question is, you tell me, calculate how many degrees is 1 radian. 1 radian is how many degrees? Simple topic math. 1 radian is how many degrees?
60 degree. Yeah, I'll get into the step. There are three. The sum of angles of a triangle is 180 degree. So there are three sides, three angles. So if you divide one angle with the sum, we'll get.
Yeah, but actually this is not perfect equilateral triangle. Avinash. Your thinking is good, but this is not perfect equilateral triangle. This, if you draw a straight line, it won't be equal to R. This is R here, this is R here. If you draw like this, it won't be R. It will be slightly less than R is this arc is R. Arc. There's a curve, na? This arc is R. If you draw a straight line, it won't be R. It's slightly lesser than R. So your thinking is right, should be like slightly lesser than 60 degree.
Number of R in 2 pi R.
Number of R in 2 pi, brilliant. See, Shuganbar got toffee maths. She is now thinking in toffee maths way. So she is telling a very simple thing. How many R's are there in 2 pi R? Is it not? The whole circumference is 2 pi R. In 2 pi R, how many R's are there? So if you get that, 360 divided by that, right? You see, circumference is 2 pi R, right? So you want all.
Yes.
Yeah, now if you draw this, you will get like this. Why? 2 pi means what? 6.28, right? 2 into 3.147. So that means how many such pieces will be there? 6.28 such pieces will be there. This is 1 radius, 2 radius, 3 radius, 4, 5, 6. But circumference is not 6R. Circumference is 2 pi, 6.28. What is this value? This value?
Point 0.28.
That is 0.28R. See, so normally people will think when you draw, when you make flower petals for Onam, Pookalam and all, we will normally what we will do, we will take a thread and draw a circle, and people think 1 radius, you catch 1 radius point, from there you catch this radius and then it will make mark, 1 mark, 2 mark, 3 mark, 4 mark, 5 mark, 6 mark. So that is how we divide the circle into 6 pieces. Normally you made it 6 pieces. But normally you will make there will be small difference. People don't realize that is because of this piece. Actually it is not exactly 6. Normally when you drew, you will take a thread. With a thread you will draw a circle, and using the same thread, that is the radius, you will make marks. From one point you will cut next, from point you will cut next. But then there will be a small piece pending. Actually that is this. So people like us who understand mathematics, when we make Pookalam, we will do a cut and make it a bit more than that, so that we get perfect 6 divided by 6. Yeah, you understand? These are the daily applications.
Yes, sir.
So yeah. So has anybody faced this problem?
Me, sir, on our competition our group also did. There was a small fraction, but
Yeah.
trying to.
Yeah, now you understand why that small difference is coming. That is this 0.28R is the one which is putting into trouble. So what will people tell? No, you are not made proper measurement. Do it properly. So we are thinking we are not doing properly. That is why. So it is the maths which is doing the trick. It's not your mistake. Yeah. Okay. So now how do we calculate? You know total angle is 360 degree. Right? Now this is simple coffee maths. 2 pi r centimeter makes 360 degree. 8 toffee is 40 rupees. How much is 3 toffee? What did you do?
Divide the.
You calculated unit value. See, get into basics, get into fundamentals, right? So assume the whole circumference is 2 pi r centimeter. 2 pi r centimeter makes 360 degree. You want to know how much r centimeter will make. This problem is same as 8 toffee cost 40 rupees. How much 3 toffee will cost? What did we do? We calculated the value of 1 toffee. So here we will calculate the value of 1 centimeter. How much will 1 centimeter make angle? 8 toffee cost 40 rupees. 1 toffee cost 40 by 8. This is same. 2 pi r centimeter makes 360 degree angle. 1 centimeter makes 360 by 2 pi r. Do you get that? Don't get into complex thinking by seeing the numbers. Numbers may become complex, but the principle remains same. Now, once you got a 1 centimeter circumference, 1 centimeter arcs make this much angle. So, how much will r centimeter make? Into r. 40 by 8 into 3. This is same. Do you get this?
Yes.
So this r and r will cancel. So you will get 360 by 2 pi. 360 by 2 pi is 360 by 6.28, 57.3. Slightly less than 60. This is not 60. Why? Because this is not divided into 6 equal pieces. There is 0.28. And you can also find this out based on the method, second method, which is what Shivananda told. How many r's are there? How many r are there in 2 pi r? How many r's are there in 2 pi r?
2 pi.
2 pi r's are there, right? Or 6.28 r's are there. So 2 pi r's are there, which means 360 divided by 2 pi. That is this 360 by 2 pi. Same thing. Both methods yields the same answer. Actually, why are you struggling here? You're struggling because whenever I was telling you was get into fundamentals of topic 8 of 3, the GP problem. See, that's why I'm telling you all the times, don't jump steps, understand the process correctly, understand the fundamentals correctly, so that when complex problems come, you can use it. Okay? So get your fundamentals thorough in simple problems, and that time don't bother about complex problems. Once the fundamental is correct, then apply it for complex problem. When the complex problem comes, don't get bothered by seeing the number. I may tell 2 raised to 85 electrons weigh 43.5 grams. How much 5 atoms weigh? Very simple. Whether it's 2 raised to 85 or 5 raised to 85, I want to calculate for 1 atom. So this divided by this. And for 5, multiply. Don't bother about numbers. Right? It is like getting into heavyweight boxing. If you look at the opponents, you man, look at his muscles and those things, you know, you will get into trouble. Forget about it. Focus on your fundamentals. Look, where is the heart where you have hit? Be clear about that.